So now in this video we're gonna look at my other relay. So I just did a video on a different relay, and I've had this one actually since I pretty much started probably my YouTube channel. I probably already had the Make Electronics Kit #1. This relay came with it, and the Make Electronics book. The project for the relay did not look too fun to me for whatever reason, and so I had trouble learning about this component, but I think I got a fairly good grasp on it now, and I'm going to learn a lot more about relays and hopefully do a lot more material. So in any case, this relay here, you can see these two LEDs are on. There's no voltage applied to the coil, so I'll lay this flat, we'll get a better look at it later on. But right here you can see the relay and the power supply at the same time. So we can raise the current. This limits current pretty good. And I'm going to just slowly raise the voltage. You can see we're at about 10 milliamps going across the coil there. And when we get to about 7 volts, something interesting happens. Still only about 20 milliamps. I went a little too fast, but I wanted to show you here that you saw it switch. That's the main thing. But at about 7, little more than 7 volts, that one goes out for some reason without that one turning on. But we raise it a little bit, that goes there. So I don't know if that's kind of a faulty part to that or not. But definitely switches when we get a high enough voltage, so I think that's good. It's rated for 12 volts, and we don't have to go all the way to 12 volts, but we could. And then when we lower it enough, it'll turn off. So I think most people just jump between 0 volts for off and then 12 volts for on. Now I'm saying off. We have 2 LEDs on though, so I don't know the correct terminology for all this. I'll learn about that and update videos later. But right now you can tell that this is a normally closed switch. There's no power going to the coil, and these LEDs are on. So that's normally closed when it's on without having to push it or give it a signal or whatnot. However, the switch is switched, and then these LEDs are off. So this is normally open. It's an open circuit now. No current is flowing until we apply a big enough signal. So running enough voltage across the coil. Now it's switched. So now it's on, but it's not normally on. It's on because we're forcing it to be on. Whereas now these ones, they're open, they're off, but only because we forced them off. They're normally closed. So now I wasn't sure if polarity mattered for the coil there, but turning up the voltage, if I go to 7 volts to begin with, which as I said before, probably nobody else does, but I got that little thing. So it's 7.5 volts now, it's doing that now. I think the voltage changes though as it heats up. But in case I raised it a little more, it flipped just fine. So it doesn't look like polarity matters, but you may have noticed I had this LED here, and I'll talk about this LED coming up. But I want to put the bench power supply back the way it was. So I'm going to put the anode there and return the power supply the way that I had it. So now at this angle, should be a little easier to see what's going on. Let's zoom back, and we have the bench power supply, in this case, plugged into here. So there's 8 pins. One there, one there, one there, one there, and then the same across there. It is a little tricky though to know where it is. I had to kind of like angle this when I was lining up the components to try to see where they were. But in any case, 1 pin on each side for the power supply, and then 1 output pin where the anode of these LEDs are, because you can see the resistor goes to the negative rail on the other side. So cathodes connect to the resistor, goes to the negative rail. And then right here we have the input for what we're switching, and it's an alternating current relay, so polarity doesn't matter. And over here we have another pin where we have the anode for that LED. Cathode again goes to resistor and goes to there. And so it's a double pole, double throw switch, because if we yank this out, it doesn't affect, if I can get a good grip on that jumper, there we go, that LED went off, but that LED stayed on. And let's see if I can make the connection again. It's a little tricky. There we go, good. It's a little hard to tell where the pin is. They're not terribly long, and the whole unit covers it. So in any case, let's get this back on. Let's get to the resistor on top and talk about it for a bit. So this should actually probably be a rectifier diode, but LED is going to work just fine. They're diodes. So we have positive over here, negative over there. Current is going to flow through the coil once I turn the voltage high enough. Let's put it to 12 volts, since I think that's what most people will have it at. So point of this LED, it really does nothing for the circuit at all. But if you notice, when I yank this cable off now, that we have 12 volts and looks like about 30 milliamps of current going through, so less current than through the coil of the other one I did, the other relay I looked at. But in case, watch that LED, and you'll see there's a brief flash when I yank this out. See if I can kind of jiggle it. And so the reason why that's happening is we're going to talk about conventional current. That's the imaginary flow of electricity that we normally use when we're analyzing circuits. You could also think of electron flow, which goes negative to positive. Doesn't matter, but usually people talk conventional current. So you imagine the flow going positive here towards negative there. So what happens is the coil actually builds up a magnetic field, which is actually how it switches it. Based on that magnetic field, it moves a magnetic material away from it or towards it or whatnot. So in any case, it builds up. Whenever you have a coil passing current, it builds up a magnetic field, and when you yank that, the field collapses. And what that does is current's flowing this way, as we said before. If we think conventional current, when you yank that out, current still flows through the coil. It doesn't, well, the magnetic field is collapsing, it keeps pushing current. And so now we give it a path to go through the LED. Whereas, like right now while we're powering it, current wants to go that way through the LED, positive to negative, but that's the cathode. The anode's over there, so current doesn't flow positive to negative through the LED that way. But when we yank that, we get that brief flash while the magnetic field collapses. It's pushing current from positive to a negative that way until the magnetic field collapses and there's no more stored energy. So now let's do a quick step-by-step build circuit, get a little more experience with this component. It's good to make a bunch of circuits when you're learning a new component. So HLS 14F3L DC12V C is the part number, as you can see there. You can Google it and get the data sheet, learn a whole bunch of stuff about it. So to begin with, we're actually going to ground the center pin this time. But there you can see the pins. We got the 2 pins for connecting, in this case, a bench power supply to give our control voltage. And so I'll make sure that lines up with those 2. And then make sure the center pin comes to where this jumper is. So this is what I was talking about, angling it before, making sure it's in the same row. So right now we'll take a mental note. There's a single gap between the center pin and the 2 other pins. We'll plug it in. Now the pins are completely gone, completely covered, I should say. And let's zoom back so we can see what we're dealing with. So instead of being at positive this time, we're at negative. So we're going to take the LEDs, and as we said before, and you should probably know by now from basic electronics, the positive, the anode I should say, the longer lead here, it needs to be more positive than the cathode. So we got the most negative point of the circuit there. So we're going to want the cathode. Where the pin comes, remember there's a gap, and so next to that gap we got the pin that's where we want the cathode, and that's for both of these LEDs. So I'm working my way up with this one. I'm going to work my way down with that one. And so we got one gap, and then the next row I'm going to put the cathode, long lead the anode. We're going to put down a little farther, and we're going to take 220 ohm resistors here. We are dealing with 5 volts at the rail here. Yeah, 12 volts going through the coil, other than changing the position of the switch, does not affect the voltage at all at this area, just which side is getting the full voltage of 5 volts of the rail. So we will put that there, and then this resistor here, make sure it's going to positive again, and let's turn on the breadboard supply. So that LED is on, the bench power supply is off, but even when we turn it on there's no voltage yet, so we stay in this position. Let's increase the voltage quickly to, right now it's about 9 volts, and that LED comes on. So that's really about it, and that's about all I know about this relay right now. Hopefully I'll have future videos where I can cover a lot more stuff that is relevant to people that know more about it. But for now, I think this is alright. It's a pretty cool component, but I don't see very many easy circuits for a demonstration for them. So the pin layout was pretty confusing to me for a long time. So hope this helped you, and see you in the next one.